All right, we're done with that. Now let's get down here to the reading computer outputs. And of course, you don't know which outputs you're going to be given on the exams, so you want to kind of prepare yourself to deal with whichever one comes your way. So here's StatCrunch, here's Minitab. Of course, I could throw a different one in there. So let me type up the answers. I'll be right back. Okay. So how many students were sampled altogether? This was, by the way, a 2009 JCC survey of students. So you can see right here, total is 446, or down here in Minitab, they say N is 446, so that's 446. How many students said they were pursuing an associate's degree? So that's what this was a proportion of. So that was 300. So there's 300 right here under the count, or right here under X. What was our confidence level? You got to kind of fish around. In the Minitab output, it says it right here. 95% CI, that's confidence interval. And then up here, it says right at the top for the StatCrunch output, 95%. Then what was the critical value? Well, that's not given to you in the output, but we know how to find that from before. Use the norm inverse function, norm.inv or norminv, and then you take 0.975, 0, 1. Or you could do 0.025, and that'll give you negative 1.96, which is fine, and then just make it positive. Right? We learned that way back. Oops, I just, there, read this one. And then or you could use StatCrunch to do it too. That'll be fine, right? Use 0, 1 for that. Okay, so then, oops, where we are. Okay, so that's how to find that. We already found those before using norm inverse, 0, 1. Then what was the confidence interval? That's the 0.629, 0.716. And they give you more decimal places here than you really need, but keep as many decimal places as asked for. So this one, 3 decimal places is fine, 4 is fine. Now, what's the margin of error? Remember, the margin of error is the distance between the outer edges of the interval, which are these two numbers, and the center. So it would pay if we found the center first. Now, you could find it by adding these two up and dividing by 2, or you can notice they gave it to you right here. Sample proportion, 0.6726. Sample p, 0.6726. That's p hat. Okay, so that's the center of your interval. So to find the error, you just subtract. You say, okay, 0.716, take away 0.6726 or 0.673. Okay. So I guess if I wanted to be more accurate here, I could put 4 decimal places in. That way, it's consistent. All right, so I will just go grab a calculator, grab Excel, whatever. So 0.7162 minus 4.6726. There you go. So the error is 0.0436. You could also have gotten it, and I'll just show it to you right here. You could get it by doing 0.6726, take away 0.6291. See? Now, why are they off in the 4th decimal place? That's because that's where we rounded to. We rounded to the 4th decimal place, so they might be a little bit off over there. Okay, that means that we are all done with section 9.1. And I think that for our Excel assignment, it would be kind of wise for us to move these problems out of here. I'm going to make them their own sheet. So 9.1 other examples. Let's do that. Examples, I can spell. And then I'm going to copy and paste in those calculations we did. Not because, they're ultra critical, but because it's good to know that you can find these things with Excel if you have to. All right, so there those calculations are right here, just to show that we know how to do them. And then we are all done with section 9.1, and I'll meet you back here for section 9.2, which is when we deal with the t-distribution and estimating the population mean instead of the proportion. See you then.